Hi, everyone. So today we're going to be looking at the last method on finding the volumes of shapes, and that is the shell method. Okay, so we've gone through the disk method, the washer method, and this one will be the last one. Okay, so you should be able to know the difference between these three and when to use them. So if I give you some curve and I say rotate it around the x-axis, you're going to get some shape. You should be able to work out what method to use and how to use it. Yeah. So sometimes I will tell you what method to use. Other times I'll let you figure out what method to use. Okay, so let's start off with the shell method. So I'm going to start off just by giving you a problem, and then we'll work out why we need this method. Okay, so let's say we've got the following setup. We've got our XY axes, and we've got the following portion of a curve. It looks something like this. Okay, so that's our curve, and it's given by y is equal to 2x squared minus x cubed. Okay, and I'll say, let's rotate this around the y-axis, and we want to work out what volume the following shape has. Okay, now just by looking at this, you might think that we should use the washer method, because if we look at our vertical axis, that's the rotation axis, we've got ourselves an inner radius, and we've got ourselves an outer radius. Okay, so you might think, why don't we use the washer method to find the volume? Well, in this case, we can't use the washer method because there's no way to find R in and R out. Okay, because this function is not invertible to find R in and R out. Because given a particular Y value, if we use that horizontal slice here, we see that it intersects at 2 points. So given a particular Y value, there's no unique solution for the X. So one of the X solutions will be R in, the other will be R out. In general, those are very difficult to find. Okay, because you would have to try and invert this formula. Okay, so in general, we can't find R in and R out by inverting the formula. Or in other words, solving for X. Okay, so in some cases, you could solve for X and then you would get your first X solution will be R in, your second X solution will be R out. So we have X1 and X2, but in general, we can't do that. That's quite difficult to do. So what we do instead is we come up with a new method of trying to find the volume. And we call this the method of cylindrical shells. Okay, so how does this method work? Okay, so instead of cutting this up into washers like we did last time, we're going to cut it up into cylindrical shells. So let's just redraw this picture so we can see what it is. So again, we have X and Y. We've got our curve. Okay, again, difficult to solve for X1 and X2, but now we're going to do something a bit different. We're going to make vertical slices. Okay, so we're going to make vertical slices like this with our thickness dx, as we've had before. And we're going to rotate these vertical strips or vertical rectangles around the y-axis. Okay, so this is going to get rotated around. So we end up with something like this. Okay, so now you can see this is some kind of cylinder with a thickness dx. So this gives us a cylinder with walls that have thickness dx. Okay, so the cylinder, it's got some thickness to it, and the thickness is dx, because that's this width that we have here that we're rotating around. Okay, what is the height of the cylinder? That's this distance over here. That's going to be y. So the height of the cylinder is going to be y in that case. Okay, and what about the radius of the cylinder? Well, we go from our central axis, we go out to the end of the cylinder. That gives us our radius. But if we're going from the y-axis out to this vertical strip, that distance is x. So in other words, the radius is x. Okay, so we've got the thickness of the cylinder, we've got the radius of the cylinder, and we've got the height. So that's everything we need to find the volume. Okay, so what's the volume of the cylinder? Okay. I'm going to leave this as a little homework exercise, finding the volume. I'll just give it to you now. So that's going to be 2 pi x. So that is the circumference of the cylinder, because the radius is x. So the circumference is 2 pi x. So it's the circumference times the height, but the height is going to be y, times the thickness, but the thickness is just dx. Okay, so that's the volume of one of the cylinders. Okay, so for this, let's just say here at this point here, we can draw the cylinder and we can find the volume of that cylinder. Now we do the same thing for all x points along the interval from A to B. Okay, so all the points along there, we do the same thing. We find the volume of each individual cylinder, we add them together, and that gives us the total volume. So the total volume will then be the integral, because we're summing up the cylinders from A to B. 2 pi x, that's the circumference. Y, that's the height. And the thickness is dx. Okay, so that's the formula that we're going to be using to find the volume of these shapes. Are there any questions about this so far? Okay, is anyone confused about the volume of the cylinder or what we're doing? Okay, cool. So that's the idea that we're going to be using. As long as you can remember this formula, then everything's going to be fine. Okay, someone wants me to go over it again. Okay, sure. Okay, so we've got this curve here. Okay, y is equal to 2x squared minus x cubed, and we're rotating around the y-axis. Okay, so that's going to give us some sort of shape. Now, just looking at this, from your past experience with the washer method, you might think if we can solve for x1 and x2, then that will give us the inner radius and the outer radius. Okay, that's what we used for the washer method. However, in general, that's not very easy. So if I just give you some random curve like this, you might not be able to solve for x. So in this case, you might be able to solve for x. So given a y value, given this y value, you might be able to invert this to solve for x. Okay. Other times you might not be. So what we need to do is find a new method to find the volume. Okay, so we're not going to use the washer method. So instead of cutting the shape up into washers, we're going to cut the shape up into cylinders. Okay, vertical cylinders. Okay, so at every point on our interval from A to B, we are going to put a cylinder. The thickness of the cylinder, or the walls of the cylinder, they're going to have some thickness. That's given by dx. Okay, so at this point over there, the thickness is going to be dx. The height of the cylinder is given by the height of the function, but that's just going to be y. Okay, that's the height of the cylinder, because that's the height of the function. What's the radius of the cylinder? The radius of the cylinder is the distance from the center of the cylinder out to the end. So that's this distance here. But the distance over there is just x, right? Because it's some distance along the x-axis, so it's just x. So we've got the thickness of the cylinder is dx, the height of the cylinder is y, and the radius of the cylinder is x. So we can just use those three to find the volume. So the volume of the cylinder is given by this formula. It's going to be the circumference times the height times the thickness. Okay, another way of imagining this is if you take the cylinder and you cut it vertically and then you unroll it. So imagine you've got the cylinder here, okay, with some thickness. Okay, that's our cylinder. It's like a tube, right? We're going to cut it like there, and then we're going to unroll it. So if we unroll it, we're going to end up with something like this. Okay, it's going to end up being a rectangle. So we cut the cylinder up, we unroll it, and it gives us a rectangular prism. The length of this rectangular prism is going to be the circumference of the circle because we're unrolling it. So whatever the circumference was, if we unroll it, it now becomes the length of this. So that's going to be 2 pi x. Okay, the height of the cylinder was given by y, so the height of this rectangular prism is also going to be y. Okay, the thickness of the cylinder was dx, so this thickness here is also dx. Okay, so that's the thickness of the sheet that we use to make the cylinder. Okay, so instead of finding the volume of the cylinder, we can find the volume of this prism. So how do we find the volume? It's just length times breadth times height. So it's going to be 2 pi x, that's the length of it. The height of here is y. What's the depth? That's dx. That's exactly what we get over here. Okay, so you can think of it in terms of the cylinder, or you can think of it in terms of unrolling the cylinder. In either case, we get the same volume, and that's the volume of one of the cylinders. But remember, we're cutting it up into lots of cylinders. At each x point, we're going to put a cylinder. So the sum then becomes an integral, right? Because we're dealing with continuous x variable. So we integrate from A to B, the volume of each cylinder, and that gives us the total volume. Okay, does that make a bit more sense? Okay, is that all right? Do I need to explain it a different way, or you're all right with that? Okay, cool. So if you ever forget the volume formula, please just remember this, this over here. Okay, when you unroll the cylinder, you get a rectangular prism, and that's easy to find the volume. Okay, so if you forget the formula, you can just use that. Okay, so that's the idea behind where this formula comes from. So let's apply it to a couple of examples. Okay, so we're just going to look at this. Sorry, we're going to look at this first example here, the one we had with y equals 2x squared minus x cubed. Okay, so let's look at that. Example number 1. So we have y is equal to 2x squared minus x cubed. Okay, so that's the same one that we started off with here. Okay, so a quick little sketch of this is going to give us the following picture. So we have x and y. It's going to look something like this. Sorry, something like that. Okay. And then if you solve this for the x-intercepts, one of them will be 0, the other one will be 2. Okay, so that is our x-interval that we're working with. Okay, so same thing as before, we're going to cut it up into cylinders like this. And then if we just extend this out, it's going to be, there's the circle for the top of the cylinder, and then it comes back down, something like that. Okay, so that's the cylinder at this point, x. Okay, if we were to sketch this as a volume, it would be something like this. Something like that. Okay, so we've got this following 3D shape, something like that. Okay, but we're interested in finding the volume. So let's use that volume formula. So it's going to be the integral from 0 to 2 pi x, because that's the circumference. The height is y, and the thickness is dx. Okay, but we know the height. We know this y value. It's going to be 2x squared minus x cubed. Okay, so let's substitute that in. So this is going to be 2 pi, the integral from 0 to 2, x times 2x squared minus x cubed, dx. Okay, so let's multiply the x inside. So that's going to be 2 pi, the integral from 0 to 2, 2x cubed minus x to the 4. Okay, so now this is just a polynomial, very easy to integrate. This is going to be 2 pi. We add 1 to the exponent to make it 4, divide by that, so that gives us 1/2 x to the 4 minus 1/5 x to the 5 from 0 to 2. So that's going to be 2 pi. 2 to the 4, that's going to be 16 over 2. 2 to the 5, that's 32 over 5. Okay, and then subtracting these, we end up with 16 pi over 5. And again, it's a volume, so if you want to, you can write units cubed. Okay, so again, everything after this point here. Okay, so once you do the sketch and find all your measurements, you just need to substitute it into the formula, and then the rest is just simple integration. Okay, so everything after that you've done before, so there's nothing new there. Okay, are there any questions about this example? Okay, any questions on this? Okay, let's look at another example. Okay, example 2. Okay, so find the volume of the shape produced by rotating the region enclosed by y equals x and y equals x squared around the y-axis. Okay, and we need to use the shell method. Okay, but that is up to you to figure out, right? So given the situation or given the question, you should be able to figure out which method to use. So there's disk method, washer method, shell method. If I give you a problem, you should be able to figure out which method to use. Okay, unless I say which method you must use, and then obviously you use that one. Okay, but if I don't say which method to use, you should figure out which one it is. Okay, so let's just draw a little sketch of what's going on. So we have x and y, and then the region enclosed by y equals x and y equals x squared. So we've got a straight line, and then we've got the parabola. So at the top, we have y is equal to x squared. So y equals x. At the bottom, we have y equals x squared. Okay, and then this is the area enclosed or the region enclosed. We want to rotate this around the y-axis, like that. Okay, so we've done this before using the washer method. Now we want to try and use the shell method. Of course, we should be getting the same answer. Okay, so let's just do a quick sketch of what this looks like in 3D. So we're going to have a circular top, okay, from this point being rotated around, and then a parabolic bottom like that. And then on the inside, the walls are straight lines going down. Okay, and then this is the solid part of the 3D shape. Okay, of course, it is empty on the inside. Okay, so we know all of that from when we did the washer method. Okay, but now we want to use the shell method. So given some x point, we need to find the radius of the cylinder, the height, and the thickness. So let's just draw a little rough sketch of what we're trying to do. So we've got some part of the cylindrical shell there. This bit is obviously going to be rotated around to give us the full cylinder. Sorry, like that. And there's the rest of the parabola going that side. Like something like that. Okay, so we need to find the radius. That's this distance here. Okay, but of course that distance is just x. Okay, the distance from the y-axis to the point along the x-axis, that's just x. So the radius is just x. Okay, what about the height? Now, the height is this blue part that I've drawn here. So we see that the height is actually the upper function minus the lower function. That gives us the blue distance. So the height is going to be the upper function minus the lower function. So that's going to be x minus x squared. Okay, so that's very similar to what we did when we found the area between curves. We took the upper function minus the lower function to get the height. Same thing over here. And then the thickness, well, that's just dx. Okay, so we've got the radius, we've got the height, we've got the thickness. We can then find the volume. Okay, so the volume is going to be the integral from 0 to 1, because that's our bounds. That's 0, that's 1, 1. Okay, we've done that lots of times now. So that's from 0 to 1. So it's going to be 2 pi x, because that's the circumference. The height is going to be x minus x squared. Upper function minus lower function. And then the thickness is dx. We times everything together, and that gives us the volume of one of the cylinders. We integrate it all up, and that gives us the total volume of the shape. So this is going to be 2 pi, integral from 0 to 1, x times x minus x squared dx. Okay, so that's going to be 2 pi, the integral from 0 to 1, x squared minus x cubed. Okay, so I've just multiplied the x inside. Again, very simple integration. Let's just do that quickly. So that will be 2 pi, 1/3 x cubed minus 1/4 x to the 4 from 0 to 1. So this will be 2 pi 1/3 minus 1/4. Okay, we can find the common denominator of 12. So that will be 2 pi 4 minus 3 over 12. 4 minus 3 is just 1. And then we're left with 2 over 12, which is 1 over 6. So this will be pi over 6 units cubed. Okay, so again, exactly the same integration that we've seen before. The only difference is this volume formula over here. Okay, so you just need to remember what that looks like. Okay, so circumference times height times thickness. Okay, and sometimes the height will be the upper function minus the lower function. So it depends on what you're given. But once you draw the little cylinder, it should be very clear what the height needs to be. Okay. Any questions about this one? Okay, no questions so far. Okay, we'll do one more example, this time with a shifted axis. Okay, like we did with the disk method and the washer method. So what happens if I move the axis around? Okay, so last example, example 3. Okay, so let's just draw the setup here. So we have x and y, and we have the following function. Y is equal to x minus x squared. So that's going to look something like this. Okay, and then just quick little check. If we let y be 0, that's going to give us the two x-intercepts. That will be 0 and 1. Okay, so that's our intercepts. There's our height, y, and we are rotating this around x equals 2. So let's just draw our line x equals 2. Okay, so this is now our rotation axis. Okay, so again, we need to find the radius, the height, and we know that the thickness is going to be dx. Okay, so if I just draw a little part of the cylinder there, so this is our thickness here. It's going to be like a big loop like this. Sorry, can do that a bit better. Okay, something like this, and then it's got the thickness. Okay, so that's our cylinder for that point. So we know that the height over here is given by y. The thickness is dx. But what about the radius? In this case, the radius is not x, because this distance over here, that distance is x. But what we want is this distance. This is the radius. Because remember, the radius is always the distance from the rotation axis out to the cylinder. So we start from the rotation axis and we measure out to the cylinder. So this is the radius. Okay, so how do we solve for the radius if we only know that the other distance there is x? Okay, well, that's not too bad, because we know that this total distance, so this total distance here is 2. So x plus r is equal to 2. R is equal to 2 minus x. Okay, exactly the same procedure that we used for the disk and washer method. Okay, if there's a shifted axis, you just need to find out what the radius is going to be. Okay, so we know the total distance is 2. The first bit of the distance is x. The second bit of the distance is r. So x plus r is 2. So r is 2 minus x. Okay. So now that we've got that, we can find the volume. Because the volume will be the integral from 0 to 1, because that is our x bounds over there. The circumference is 2 pi r, so it will be 2 pi 2 minus x, because remember that's r. The height is going to be y, but that is just x minus x squared. Okay, that's the height. And the thickness is dx, of course. Okay, so that's all the work you need to do. So you just figure out what r is, you figure out what h is, you put it in the formula, and then you've got a simple integral to solve. Okay, so all the hard work is done now. Okay, so let's do the integral. So that's going to be 2 pi integral from 0 to 1. Let's expand this out. So we're going to get 2x minus 2x squared minus x squared plus x cubed dx. Okay, so I've just expanded the bracket out. So 2x minus 2x squared minus x squared and then plus x cubed. Okay, so this gives us 2 pi, the integral from 0 to 1, 2x minus 3x squared plus x cubed. Okay, so this is very straightforward to do. We're going to get x squared minus x cubed plus 1/4 x to the 4. Okay, from 0 to 1. Okay, so we're going to get 2 pi 1 minus 1 plus 1/4. Okay, the 1 minus 1, that just goes away. So we're left with 2 pi over 4, or just pi over 2. Okay, and if you want to, you can write units cubed. Okay, but like I said earlier, everything after this volume formula is just simple integration. Okay, so we've done that lots of times now. This part is the important bit, getting all of this correct. Okay, so that's the important part. Finding the radius, finding the height, and then substituting those in. Okay, and of course, if the radius, if the axis of rotation is shifted, then you've got a little bit more work to do finding the radius. Okay, but not much more work. Okay, as long as you remember that the radius is the distance from the rotation axis to the point that you're interested in, that distance is always the radius. Okay, if you remember that, you can always find out what it is. Okay, so that's it for the shell method. Okay, so it's really not too much to go through. On Thursday and Friday, we'll be doing a few more difficult examples, and we'll finish off the shell method on Friday. But remember, tomorrow you've got your summative quiz on finding volumes using the disk method and using the washer method. Okay, so it's out of 15 marks as usual, and you will be given 3 questions, 5 marks each, okay, to find the volume. And I don't tell you which method to use. So you should be able to see from your sketch, do I use the disk method or do I use the washer method? Okay, so that counts as one of the marks. And then once you figure out which method to use, it's just applying the formula. Okay, and then that's the other 4 marks there. Okay, so the summative quiz will be a bit different than last time. The questions won't be in a PDF like we had before. The questions will be on Learn 2022, and they are underneath the heading Summative Tutorial Quiz 2 questions. Okay, so it's in the form of a little quiz. All your questions are there. Okay, so it's not in a PDF anymore. Okay, but it is written. Okay, so you do still have to show all your working, scan it, submit it, and then you'll get your marks by the end of the day. Okay, Are there any questions on that, on the procedure? Okay, so everyone understands what to do tomorrow. Okay, so tomorrow's thing will be on the disk and the washer method, and then next week that will be on all three methods. Okay, so just to let you know what's happening with that. Okay, I will post the homework question on the WhatsApp group. Same rules as always. The first one to reply with a full correct solution will get 1 bonus mark for tomorrow's quiz. Okay. Okay, so I'll post that right after this, and then I will upload the lecture video as well. Okay, so I'll see all of you tomorrow during the tutorial session. Got a question here. Can you explain tomorrow's quiz? Okay, so the questions for the quiz tomorrow, they won't be in a PDF file like we had before. They will be listed in a Moodle, in a Learn 2022 quiz. So you should see under your summative quizzes, there's a quiz there called Summative Tutorial Quiz 2 Questions. You click on that and it will show you all the questions. There's 3 questions. You write all your solutions on paper, you scan them, and then you submit them. Okay, there's a submission button there as well. Okay, so it's exactly the same as what we did last time, but now the questions are on the quiz. They're not in a PDF anymore. Okay, but I will send another email out explaining everything again. Okay, but take a look on the WhatsApp group for the homework questions. Okay, so that's 1 bonus mark for the quiz if you can get it right. Okay, so I'll see all of you tomorrow and good luck with your preparations.